Okay, in this video we will look on the switching and temporary overvoltages. Switching overvoltages, so this is the figure that you can find in IEC 60071, standard IEC. So we will have a look at this figure before. Right, so we have VFFO, we have the lightning over voltages, we have the switching over voltages, temporary over voltages, and then finally the system voltages that appear all the time in the system. So we have covered before the lightning over voltages FFO, which appear only in microseconds in the system but at very high magnitude. Alright, so in this video we will look at the slow run over voltages, switching over voltages, and temporary over voltages. So the reason why we need to understand the switching over voltages is because we need to determine the over voltage level due to the switching event. So switching event appears quite often because of switching the breaker and so on. So we need to determine the insulation levels, and then we can assess the surge arrestor requirement and compliance, then identify network resonance issues. So these are some of the reasons why we need to understand the switching phenomena in the system. So sudden changes in electrical network structure give rise to transient phenomena. So switching over voltages is transient in shape. It rise and then decay. It's a transient waveform. This causes the creation of over voltages or of a high frequency wave train of a periodic or oscillating type with rapid damping. So disappear when sudden changes in electrical network structure, right? Structure itself. For example, when the arc between circuit breaker contacts break, so when we open the circuit breaker, the full system voltage suddenly appears across the open gap and hence across the circuit. So the whole circuit consisting of RLC now change, because when we open the breaker, that can cause arc, and this can cause switching over voltages. So the result voltage consists of a high frequency component superimposed into the normal voltage. So the total is known as restriking voltage and constitute a switching surge. For example, here when this is the normal operating voltage waveform 50 Hz, then when there's a switching occur, open up the breaker, and then the switching can cause the switching voltage over voltage appear in the system, right? This type of phenomenon occurs on electrical networks undergoing a rapid modification to the structure, opening of protection device, opening and closing of control device, breaker, and so on. So this is an internal sources of overvoltages, right? Compared to the external source of overvoltages, which is the lightning. The surges generated are normally propagated in the form of high frequency wave and rapid damping. However, if we look at this is the front waveform. Okay, 0.25 millisecond, 2.5 millisecond, or 25 microsecond, 2500 microseconds. So the front time and the decay time, right? So switching over voltages, also known as slow front over voltages, it is a bit slow compared to impulse. So impulse is fast front. Internal over voltages, depending on the system voltages and conditions, their surge magnitudes vary from 1.5 to 4 per unit or even higher, right? Examples can be generated, examples of how switching over voltages can be generated are switching operations, closing and reclosing of line or breaker, fault initiation and fault clearing, alright, load rejection or energization, interruption of inductive or capacitive current. So this all basically going back to this point here, sudden changes in electrical network structure. Alright, the whole network structure consisting of several equipments components. Right, so what happens when there's changes to this, each of these um, elements in the system that can cause switching of voltages, right? Um, so switching over voltages are important for insulation coordination system design for voltage above 300 kV. It can be unidirectional, okay, just one directional, or oscillatory, and often contains many harmonics, right? This compared to the lightning over voltages. This is a bit oscillatory compared to the lightning, right? SFO waveform are normally slow fronted and of short duration. Okay, so typically the front time is between 10 microsecond to 300 microsecond. The decay time typically between 300 microsecond to 3000 microsecond. However, the standard, so we put a standard common value, standard switching waveform normally generated in the laboratory has a T1 value of 250. Sorry, my mistake, I said 25 micro, sorry, it's 250 microsecond, right? And T2 value of 2500 microsecond. So 250 slash 2500, okay, compared to 1.2 slash 50 microsecond for lightning, right? So this is a bit slow, 250 slash 2500 microsecond. All right, 250, 200, 2500, right? So 2500 microsecond for the overvoltage to from 0 to rise and decay reaching 50% or 0.5 pu. That is the time, that is the decay time, the T2 time, right? For TP or T1, that is the time from 0 to 1.0. That is the time required or time taken for the impulse or the overvoltage to go from 0 to 1 pu. Okay, so so switching impulse or switching over voltage you can find in the table here. Switching impulse test, right? So origin of switching surges may include any of the following: de-energization of transmission line or cable. So transmission lines or cable are basically capacitive element. So when we de-energize the transmission line or the underground cable, that can cause switching surges. Also disconnection of unloaded transformer. So transformer itself contains HV winding, LV winding. So these are inductive elements in the system. So when there's a disconnection of transformer in the system, that can cause switching over voltages as well. And then energization or reclosing of lines and reactive loads. So these are the loads when we energize or reclose lines that have reactive loads that can cause switching of voltages as well. And also when there's short circuit fault clearance. So during insulation failure, live conductor is suddenly earth. So this may also cause sudden overvoltage in the system. And then finally, the origin of switching surges may include a resonance effect. If EMF wave produced by alternator is distorted, the trouble of resonance may occur due to fifth or higher harmonics. So this is one of the reason that can cause switching over voltages appear due to the alternator or the generator. So let's compare between lightning and switching over voltages. So voltage surges appear in the electrical power system. Due to switching surge, insulation failure, arcing ground, and resonance are not very large in magnitude. Alright. Due to switching surge are not very large in magnitudes. These overvoltages hardly cross the twice of the normal voltage level. Alright. Generally, proper insulation to the different equipment of power system is sufficient to prevent any damage due to these overvoltages. But overvoltages occur in the power system due to lightning is very high. Alright. So if overvoltage protection is not provided to the power system, there may be high chance of severe damage. Hence, all overvoltage protection device in the power system mainly due to lightning surges. Okay, so we have discussed that we have lightning and switching over voltage in the system. However, as we can see here, that the lightning over voltages are very severe, can cause severe damage. It has high magnitude, so that's why usually when we study over voltage protection device in the power system, mainly because we want to protect from the lightning surges. Alright, even though switching over voltages appear in the system, however, as you can see here, these over voltages hardly cross the twice of the normal voltage level. I believe in the previous video I've shown that this is the example maximum can go up to 4, but it can vary between 1.5 to 4 per unit. Okay, yes, here vary from 1.5 to 4 per unit or even higher. However, as you can see there, that the surges hardly go above 2 per unit. Alright, hardly cross the twice of the normal voltage level. So proper insulation to the different equipment of our system is sufficient enough to prevent any damage due to this overvoltage. But we need extra overvoltage protection device, mainly to protect lightning surges. So lightning surges is more critical in the system.